Algebra 3, this is lesson 43. We're going to talk about periodic functions and graphs of sine and cosine theta waves. Okay? We're going to look in our book a good little bit here so that you understand. Now, some of this, it goes like deep into the theories behind it, how it's related to like unit circles. And you can see that start off with like 43.B in your book on page 309. Basically, what we're looking at, both cosine and sine waves are what are called sinusoids. So even though it says sin, doesn't mean just sine, although they're related to each other. A cosine theta is another type of sine wave. Basically, what has happened with a cosine wave is that a cosine wave is a sine wave that has been shifted. So that won't make a whole lot of sense today. It'll make a little bit more sense later on when we get into like really complex type of sinusoid questions where something looks like a cosine wave, but it says, you know, write this off as a sine wave. So we actually have to counteract the shift. So that it's not as complicated as it sounds once you know what's operating and how it works, but it's really complicated right now. So I don't mean to take it any further than that.
We're going to start that stuff.
That stuff will not necessarily be fourth quarter, but from January through like the early part of February, we're going to be all ACT prep. But as soon as you guys take the ACT, the day that you come back, we're back in the book. So it's your third quarter is not just ACT prep. You know, about maybe a month and a half of it is. But, you know, let's see, third quarter's over in what, early March? So about half of it's ACT prep, the other half we're back in the book. So anyway, yeah, you in school in May. No, May. All right. So what I want you to do is I want you to to your book. Let's see, where do I want you to start off? Let's look at page 311, because what I want you to see is what a period change is. A period change is how many degrees until a graph gets back to the same position. Okay, so if we're looking up here, you know, notice this point right here. All right, do you see that spot? Okay, so we're going to follow it until it gets back to the same position. Okay, so you tell me when to stop. Okay, you're absolutely right. That is a complete period. Okay, now the standard period is 360 degrees. All right. Everything, any other kind of period change is based upon going through a period closer, which is going to become, you know, a multiplier, meaning that, you know, if I was going through two periods in 360 degrees, that would be 2. You know, it'd be like 2x, something like that. Okay. And so the more periods I get through in 360 degrees, the more it begins to look like this. Okay. Now, I may only go through half a period in 360 degrees, so it's going to be stretched out, okay, more than normal, right? This is what we might look at as standard. So if I wanted to know what the actual period is here, though, notice that I have a mark at 90 and I have a mark at 270. So this mark here in the middle is somewhere between 90 and 270, right? So I would take 270 plus 90, right, which would give me 360. 360 divided by 2 is 180. So I know that that mark there is at 180. Here's 90, negative 90, negative 270. So the mark there is negative 180. So what is the degrees between those 2 points? How many degrees does it take to get from negative 180 to positive 180? 360. So it has a standard period, right? It goes through one complete revolution in 360 degrees. So do we understand periods right now? Okay, phase shift comes in later. We're not necessarily worried about phase shift. The other thing I want you to see is how do I identify a sinusoid as cosine or sine wave? Okay, just without any kind of shift, this is what you want to notice. That a cosine wave will hit its peak or max on the y-axis. Okay? So this is a cosine wave because it reaches its minimum on the y-axis. Okay? If it reached, let's say it went like this, it would still be a cosine wave. It would just be a positive cosine wave. What you see here is a negative cosine wave because it crosses the y-axis in a trough. Okay? In fact, at the minimum of its trough. Does that make sense? Now, a sine wave is what you see with number 2, meaning that it's coming up and it reaches halfway through its either rise or drop on the y-axis. Okay? So that's what you see as a sine wave. Now, they're both sinusoids, but one's sine and one's cosine. So can we identify the differences between a sine wave and a cosine wave? All right, go real quick. If you're still in your book, take a quick look at page 311. And you should see, let's just look at that top graph real quick, the one that has all the lines through it. Just without looking at it real closely, is that a sine wave or a cosine wave? Sine wave. All right, you have 2 graphs in the middle of that page, one to the left, one to the right. The one to the left, what kind of function is that? What kind of what kind of sinusoid is it? Sine or cosine? In the middle of the page on page 311, the one on the left. Sine. Is it positive sine or negative sine? Positive, because it's going up from left to right. Okay? What about the one to the right? Negative sine. Okay? Negative sine. Now look at the one at the very, very bottom. Cosine, positive or negative cosine? Positive cosine, because it's reaching its max on the y-axis. Is anybody lost in here at all? Do I need to go back? Okay. So you should be able to see. Now, the next thing I want to talk about is amplitude. Amplitude. Okay. Amplitude, if you look, let's see. What we're going to look for is in a cosine wave, we're going to look at where it's reaching that min or max. Okay. Right here, its amplitude is -6. Okay, because it's crossing that y-axis at a minimum. So it's not just a negative sine or negative cosine, it's a -6 cosine. Okay? Now, down here, because we're reading it from left to right, this is a sine wave, but its amplitude is what? Meaning that we're going to look at what it does as it crosses to the right. So we're looking, is it going up? Yes, it's going up. It's positive. What does it reach in terms of its max? It reaches a max of 5. All right? So we're saying y equals 5 sine, and then we're going to look at what, it may either use cosine, or sorry, not cosine, but either x or theta. And so we're going to look and see that says, x. So our answer is y equals 5 sine x. All right, so the other thing I want to talk about is order. Whenever we go to write these off as a function, we want to put things in a specific order. Okay? The first thing that we start off with at this point in the game is we're going to start with amplitude. Okay? Yes, it's elevation either up or down. Okay, so it's either positive or negative. And then function. Okay, function meaning is it sine or cosine? Okay, so that's what we're worried about right now is amplitude and then function. All right, so let's look at this first one up here. What is the equation for this first graph? We're going to start off with y equals, what's the amplitude there? -6. And then I want the function. What kind of function is this? Is this sine or cosine? Cosine. And am I using x or theta to represent my wave? x. So negative 6 cosine x. Now we'll add more things to this later on, like phase shifts and period changes. Right now, we really don't have much in terms of period changes, although you can see that on page 312, where we can get some different period changes. Okay? All right. Let's come down here for a second. So we understand 1, understand 2, but let's look at number 3. It says graph y equals negative cosine minus 2x. This right here is the period. Okay? So that means we're going through 2 periods in 360 degrees. Okay? So just to kind of add to our list, we have amplitude, function, x or theta, and then period. Okay? Oh, there's one more thing that we haven't included, because we can shift the whole graph up or down. So typically speaking, we really don't have to worry about it too much, but that is what we call the center line. And if the center line is 0, like it is in either of these two cases, we don't worry about it. Okay? So we have center line, amplitude, function, then our x or theta, okay? And then period change, and then later we'll add phase shift to that. So the way that I've had kids remember this, or to remember the order and how we write these functions, is CAF PP. CAF PP, okay? So center line, amplitude, function, period, period change, phase shift. Now, we don't always use all of that because not all the time is it being applied, right? And so I say that because it is funny, and because it's funny, it's easier to remember. Okay, CAF PP. CAF PP. There you go. What's that? Yeah. All right, so let's go over now the negative 2 part of this. I don't know why they've got it there. It's not really necessary. Okay, but if we're going to draw this, okay, notice that it said y equals negative cosine, right? Negative cosine. So where is it going to cross the y-axis? At negative 1, right? So negative 1. And is it going to cross going up? Or is it going to, is it going to cross coming down? Okay, you already kind of said negative 1. But I guess the question I'm asking you is it going to cross the origin, or is it going to trough at negative 1? It's going to trough, so it's going to come down here. Now, let's go ahead and break this into 90-degree segments. So, I've got 90, 180. What, the next one would be 270? Sorry. 360, right? Okay. All right, and we needed to go through 2 period changes. We need to go through 2 complete periods in 360 degrees. So it needs to end down here, right? And so it also needs to come down here again somewhere between 0 and 360, right? All right, so what's halfway between 0 and 360? 180, okay? Let's see if I've got this right. Yeah, it's just that my spacing's not very good. Okay, so it's going to come here. Now, the other thing that you need to understand is that it's going to go an equal distance up, right? Right? So because it doesn't have a different center line, it's not been moved, so I have to go up every bit as much as I'm going down, okay? Which means halfway between my troughs, I'm also going to hit a peak. Does that make sense? All right, so if I draw those lines, now I know where I'm going up to and when I'm coming down, and I can make that curve a little bit better. So I'm getting something that looks like that. All right, does that make sense? All right, so in order to draw it accurately, you kind of have to set everything up beforehand. Don't just start making a curve, or making that wave and then try to fill in your numbers later. It won't work out. All right, you want to set everything up beforehand. Do we understand how we went about doing this? We should have everything in order here. All right. Now, the other thing I want you to understand about some of these questions is that a lot of times they're going to list things not in degrees but in radians. So you also want to understand that 360 degrees is the same as 2 pi. 180 degrees is the same thing as pi. 90 degrees is pi over 2, right? Those types of things, okay? So if they list the question in radians, your graph has to be in radians, okay? So what's easiest for me is to convert everything to degrees and then back to radians and go ahead and list both. Okay? Okay. Number 4. Number 4, graph y equals sine x. Okay? So did they change the center line at all? Or is it still just the center line is 0? Center line is 0. What's the amplitude? Amplitude is 1. Because it's a sine wave, is it going to hit a peak or trough on the y-axis, or is it going to cross through the origin? It's going to cross through the origin. And is it going to be positive coming up, or is it going to be negative going down through the origin? Positive going up through the origin. And is it going to, how many periods is it going to go through in 360 degrees? Is it going to go through 2? Is it going to go through half of 1? It's just going to go through 1. All right. Now, the handy thing about question number 4 is that what do you notice about at least 3 of those graphs? They're what? Are they sine functions? No, they're cosine functions. Is A cosine or sine? Cosine. Okay. What about B? Okay, except it's a negative cosine, right? What about D? Negative cosine, right? All right, that's negative cosine, cosine. This is the only sine function. Notice that's going up. It goes up to 1 as it crosses. It finishes a period at 360 degrees, so it matches everything that we need it to match right there for number 4. Do we feel like we understand? I know, like I said, there's a lot of stuff here to consider. Center line, amplitude, type of function, and period change. All right, I'm going to let you guys, well, hold on. Let's see, is there a question? Do you guys have number 7? Yeah. 7 and 8? 7 and 8 are from this lesson. So I want to see how well you guys do with these. Look at number 7. What type of function is that? Okay, well, let's just address it. Does the center line change at all? No, because the average between 4 and negative 4 is 0, right? Okay, so the center line didn't move. Okay, so I have y equals. Okay, and I don't need to include a center line change. Okay, what's the amplitude here? Number 7, what's the amplitude? Is it positive or negative? Negative. All right, negative what? Okay, so it's going down 4. What type of function is it? Is it sine or cosine? Okay, cosine. Are they using x or theta? They're using theta. All right. In 360 degrees, how many periods does it go through? 1. So I don't need to, there doesn't need to be anything in front of that, right? Okay. And that's where I would put it right there, as if there was a period change, I'd put it in front of that x or theta. Okay?
So if there's 4 periods.
Yeah, if there was 4 periods, if it was going through a rotation 4 times in 360 degrees, it'd be y equals negative 4 cosine 4 theta. And it'd probably be listed like that. Okay? All right. Look at number 8. Number 8. Okay, we got our y equals. Okay, do they change the center line at all? No, because the average between 5 and negative 5 is 0, right? Okay. Let's see. What's the amplitude there? Positive 5. It's going up as it crosses through, right? 5, what type of function is it? Sine function. Let's look at the period real quick. Where does it cross again at? Notice it crosses at 0. When does it cross the center line going up again? At 2 pi. What is 2 pi the same thing as? 360 degrees. So how many periods does it go through in 360? 1. Okay? Do they use x or theta? X. So my equation is y equals 5 sine x. This is, what's that? In terms of period changes? Yeah, there absolutely is halves. You just haven't seen one yet. I'm trying to, and they're not showing you one yet. They're not really pushing you guys as far as period changes. I'm introducing it to you so that you understand it. Phase shifts are where things get a little bit more complicated. That's when we start looking at a phase shift. That's translating a graph, because eventually you'll see something that looks like this. Okay, notice that it's not crossing at an exact, right? Right, so we actually have to shift it in order to name it, in order to get the function for it. Okay, that's when things get a little bit more complicated, because at this point I can write this either as a cosine or sine function, so my rules will change depending upon how I want to write it. I'll tell you whenever we get there. There's not really any point in adding more information than you need at this point, okay? And because we're going to look in the book, we'll read the book and we'll read the definitions and how things work and look at illustrations when we get to that point. That'll make a lot more sense when we get there, okay?